Hello everyone, welcome back to our lesson video 6. Today we are going to talk about imperative statements and why they are important. And why they are important. And also learn about the three main types of loops in C++. We also practice. So what are imperative statements? Imperative statements are commonly known as loops. Imagine you are asked to write the numbers 1 to 100 on a piece of paper. You can write each number manually, but that would take forever and be very tedious. Instead, you would probably want to find a particular system to make it easier. That is exactly what loops do in programming. They execute a piece of code repeatedly based on a condition or set of conditions. Instead of writing the same code over and over, you write it once and let the computer repeat it as many times needed. Loops are essential for programming repetitive task efficiency. Without loops, programming would be incredibly tedious and many tasks would be practically impossible. In C++, there are three main types of iteration statements. We have a for loop, while loop, and a do while. The for loop best when you know exactly how many times you want to repeat something, and while loop is best when you want to repeat something as long as a condition is true. And the do while loop is similar to the while loop, but always executes at least once. So for statements are uh, statements is used to iterate over a range of values or elements in a collection. It is like telling the computer, do this task starting from here until you reach there and change by this amount each time. Let me break it down. Initial statement. This runs once at the beginning, usually to set up a counter. The condition. This This is checked before each iteration. If true, the loop continues. Update statement. This runs after each iteration, usually to change the counter. And we also have and this is the syntax. The syntax for a statement. We have initial statement, the loop condition, update statement, and statement. So how loops execute. Understand this process will help you write better loops. Here the step-by-step process of how loops execute. First, the initial statement executes. This happens only once. And second, the loop condition is evaluated. If the condition is true, execute the loop body, then run the update statement. If the condition is false, exit the loop completely. Third, repeat step 2 until the condition becomes false. The variable in the initial statement is called the loop control variable or index variable. It controls how many times the loop runs. So we also have a infinite while loop. The importance of while loop consideration. Infinite loops can be dangerous. They continue to execute endlessly, which can freeze your program or computer. You can avoid infinite loops by including statements in the loop body that ensure the exit condition will eventually become false. Always make sure your loop has a way to end. And this is the syntax, for example, for loop statement. Example, for int I equal to 0, I is less than 10, I increment, which means for integer I equal to 0, I is less than 10, and increase I by 1 each time the program is executed. See out I. So for the while loop, it executes as long as specific condition evaluates true to true. How a while statement executes its control statement until its condition becomes false. And this is the syntax for the while loop. Bring your while, your expressions, and your statement. And statement can be a simpler or simple or compound. Let's talk about the do while loop. The do while statement is similar to the while loop, but with one important difference. The condition is checked after the loop body executes, not before. This means a do while loop always executes at least once, even if the condition is false from the beginning. And this is how we write it. Int I, int I equal to 0. Do cout. Output I and increase I by 1 while I is less than 10. So this code is going to execute I equal to 0, 1, 2, 3 up to 9 because while I is equal to 9, that's how the do while loops will behave. So exiting from it. If the condition of an iteration statement for while or a do statement is omitted, the loop will not terminate unless the user explicitly exits it by a break, return, go to, throw, or some less obvious way such as call or exit. So the break statement breaks out the nearest closing loops or switch statement. It's like an emergency exit. When you hit brake, immediately leave the loop and continue with the code after the loop. We use the brake when we need to leave the loop body in the middle before the normal exit condition is met. The brake statement is commonly used for exiting early from a loop when a specific condition is met, skipping the remainder of switch structure, as we saw in our previous video. An example for the brake system. For int equal to 0, I is less than 10, I increment. If I is equal to 5, output set found I, brake. So if the code runs and it founds I being equal to 5, the code breaks. It has to continue from there before it exits from the main code. Sometimes you don't want to exit completely, the loop completely. We just want to get to the end of the loop body. A continuous skip the rest of the body of an iteration statement. And we have something called nested loop. So the nested loops are loops inside other loops. This is a powerful concept that allows you to handle more complex repetitive tasks. Nested loops are like the hands of a clock. The middle hands, which is the outer loop, move once, and the second hand, inner loop, move 60 times. For each minute, there are 60 seconds in each minute. So example, so for I equal to 1, I is less than or equal to 5, I increment. For j equal to 1, j is less than or equal to I, j increment. See out. This creates a pattern where each value of I we print all values of x j. So the outer loop controls the rows I goes from 1 to 5, and the inner loop controls how many staff times or to print in each row, which is the j, goes from 1 to I. Understanding nested loops execution. So to understand nested loop execution, 1. The outer loop starts its first iteration. The inner loops complete all iterations. The outer loops moves to its second iteration. The inner loops complete all its iterations again. This continues until the outer loops finishes for the star pattern or pattern you are writing about. When I is equal to 1, inner loops runs once, print 1 star. When I equal to 2, the inner loop runs twice, prints 2 stars. And when I equal to 3, the inner loop runs 3 times and prints 3 stars, and so on. So there are some common mistakes you need to avoid when you are writing loops. For infinite loops, Forgetting to update the loop variable is one common mistake people do. And off by one errors, starting from wrong number or using wrong condition. Uninitialize variables. Using loop variables before initializing them. That's also one common mistake everyone does. Wrong loop type. Using the loop when while loop would be rather or vice versa. And nested loop confusion. Getting confused about which loop does what. And here are some tips to make your loops more efficient. Minimize work inside loops. Do not do expensive operations unless necessary. Use the right loop type. Choose the loop that best fits your needs. Avoid unnecessary calculations. Do not recalculate the same value repeatedly. Consider loop unrolling for every performance. Critical code. Sometimes manual repetition is fast. So that's the tips for you.